Welcome to Spring LIB.
So from example 4, we're going to consider the function f of x is equal to sine of x plus sine 3x. And what we're going to first do is graph the function in the viewing window 0 pi by negative 1.2 to 1.2. We want to find how many local maximum points it looks like in that viewing window we can find. And then we want to use the first derivative and the second derivative's graph to see if there are any hidden maximum or minimum values. And we also want to find what all these maximum, minimum values and inflection points are going to be. And then lastly, we're going to go ahead and graph f in the viewing rectangle of negative 2 pi to 2 pi by negative 1.2 to 1.2. And we want to comment on any symmetry we might see. So I went ahead and already graphed f of x on 0 pi 2, or 0 pi by negative 1.2 to 1.2, and just kind of eyeing it on this interval. Well, it looks like we have maybe a max here. So let's go ahead and write max. We have another max right here. And we have two minimums here. So looks like we have two maxes and two mins, at least with this viewing rectangle. So I went ahead and graphed the first and second derivative on the same graph. So the black line is f prime and the red line is the second derivative. And I graphed it on the same viewing interval of 0 pi by negative 1.2 to 1.2. So all these blue dots here are going to be our inflection points, or at least what my graphing calculator said were our inflection points. And all the green dots are going to be our possible critical values. So looks pretty standard, but one thing that might seem a little bit off to you is over here around 0.5 and 0.7, well, the red line, remember, is talking about our second derivative. And it says we're going to have 2 points of inflection here. Well, if we have 2 points of inflection, that would make you think, why do we only have one minimum value or one extreme value in between them? It would make sense to say there should possibly be more. And if we were to actually zoom into that region, you would see that on 0.57 to 0.17 for our x-axis, and along our y-axis, negative 0.005 to 0.005, we actually have two more values that occur. And if we were just to kind of look at this, to the left of 0.591, the function is increasing into this point, decreasing after. So that tells us that's a maximum. And that's by using the first derivative test. This second value here, well, it's decreasing into it because it's a negative slope to the left and a positive slope to the right. So this is going to be a minimum. And for our other value, well, it's increasing into the point and then decreasing after. So that would be a local max. And so if we were to go and look at our original function now, and we look at the interval 0.55 to 0.71, and along the y-axis 0.9999 to 1.0001, you can see that, so this we originally thought was supposed to be a maximum. But in reality, in ended up being a minimum value. So let's just kind of go back to the first graph really quick. So this is that interval that we were looking at right here. And we looked at that and we said, oh, that is a maximum. But in reality, it should have dipped down more like that. And so that point that we thought was a max is actually a minimum. So we've already found all of our maxes and mins, or at least the x values for them, along 0 to pi, and all of our inflection points. Now, the last thing they wanted us to do was to go ahead and graph this on negative 2 pi to 2 pi by negative 1.2 to 1.2. And we need to comment on the symmetry. So you might notice, one, that from negative 2 pi to 0 and 0 to 2 pi, it repeats. So it's periodic with a period of 2 pi, which makes sense because we're working with sines. And even more than that, it looks like it's symmetric about the origin. Because if we were to come up here, well, it kind of maxes out. And I say maxes out kind of in quotations because we know it should have a max, 2 maxes and 1 min around there. And on the other side, it looks like it becomes a minimum. So just from symmetry of this, we can say that this is a odd function with symmetry about origin. And so this is nice because if we found all of our maxes and mins on that interval 0 to pi, we can go ahead and take those same x values and just flip it if it's a max or a min. And then that would tell us from negative pi to pi where all of our maxes and mins are. And then we know that this is periodic from periodic to pi. And then we could just add 2 pi k to each of those x's to find the rest of our maxes and mins.